we added Juno as what we call an outreach camera, which meant that it did not have a responsibility to return scientific data.
Welcome, space lovers, to an epic journey into the heart of the giant that reigns over our solar system. Today, let us take a closer look at Jupiter's hidden wonders, as revealed by NASA's revolutionary Juno mission.
The Juno mission actually started in 2006.
From swirling colossal storms to a mysterious, fuzzy core and a magnetic field that defies expectations, Jupiter has secrets that challenge everything we thought we knew about giant planets. But do not worry, we are not giving away all the answers just yet. Instead, we will peel back the layers of mystery, one step at a time. Get ready for an adventure that is as breathtaking as it is enlightening. As we prepare to unveil the true majesty of Jupiter, one question looms large. What makes this colossal planet so captivating? Beyond its size and stormy surface, there's a deeper allure to be uncovered. Let's dive into Jupiter's intriguing features and the mysteries it holds beneath its swirling clouds. The Majesty of Jupiter, a cosmic giant's allure.
Jupiter is the king of the planets, and it's certainly the most dangerous environment that we...
Jupiter, the behemoth of our solar system, has long fascinated astronomers and casual skywatchers alike. With a mass more than 300 times that of Earth and a diameter that would engulf more than 1,300 Earths, this gas giant is not only the largest planet in our cosmic neighborhood, but also a repository of mysteries waiting to be untangled. Its swirling, multicolored bands, dominated by shades of orange, white, and brown, form a dynamic tapestry across its vast atmosphere. Among these features, the Great Red Spot.
The big red thing, the big...
Yeah, we call it the red spot on Jupiter, we call it Jupiter's red spot.
Okay.
Yeah.
A storm larger than our planet that has raged for centuries, stands as one of the most iconic images in space science. Historically, even before telescopes first captured its beauty, Jupiter was known to ancient civilizations as a wandering star. Over the centuries, as observational technology improved, astronomers uncovered more details, the detailed banding of its cloud tops, hints of a complex interior, and even the discovery of its largest moons by Galileo and Simon Marius in the early 17th century. Today, Jupiter is recognized not only for its size, but also for its role in shaping the solar system's architecture. Its immense gravity influences the orbits of countless asteroids and comets, acting as a cosmic shield for the inner planets, while also stirring up dramatic events in the outer solar system. However, what truly sets Jupiter apart is the way it challenges our understanding of planetary physics. Despite being composed mainly of hydrogen and helium, the details of its internal structure, its deep atmospheric dynamics, the nature of its core, and the secrets of its magnetic field remain subjects of active research. Recent discoveries have even suggested that, far from having a neat, solid core like Earth, Jupiter might harbor a fuzzy core, a diffuse mix of rock and metallic hydrogen that hints at a turbulent and violent formation history. As we admire this enormous planet's beauty and complexity, one cannot help but wonder how such a vast and dynamic planet came to be. Its formation, evolution, and the interplay of forces within its atmosphere continue to spark debate among scientists. In our quest to understand Jupiter, every new observation peels back another layer of the mystery, promising to reshape our understanding of not only this planet, but of planetary systems everywhere. Jupiter's beauty is both a visual spectacle and a gateway into the processes that govern planetary birth and evolution. By studying its storms, composition, and magnetic quirks,
they follow along the magnetic field lines and they come down into the atmosphere of Jupiter and they excite different sorts of interactions.
we not only learn about Jupiter itself, but also gather clues about the early days of our solar system. This massive planet, with its swirling clouds and magnetic enigmas, holds secrets that may answer fundamental questions about how planets form and why our cosmic neighborhood looks the way it does. Jupiter has fascinated us for centuries, but to uncover its secrets, we needed a mission like NASA's Juno. This groundbreaking spacecraft is not just reaching Jupiter, it's delving deep into its core, unlocking mysteries that have eluded scientists for decades. The pioneering journey, NASA's Juno mission. To unlock the mysteries of Jupiter, NASA launched one of its most ambitious missions yet.
the chamber pressures have plateaued and begun rolling off.
Juno, launched on August 5, 2011, from Cape Canaveral aboard an Atlas V rocket, Juno embarked on a 5-year odyssey covering billions of kilometers before finally entering orbit around Jupiter on July 5, 2016. This mission was designed not merely to capture stunning images,
a three-dimensional picture of the atmospheric structure of Jupiter,
but to probe the very heart of Jupiter, measuring its magnetic field, gravitational pull, atmospheric composition, and much more. Juno's design itself is an impressive example of modern engineering. Unlike earlier missions to the outer planets, which often relied on nuclear power sources, Juno is solar-powered, even at Jupiter's distance, where sunlight is a mere fraction of what we receive on Earth. Its 3 expansive solar arrays, each spanning nearly 10 meters in length, not only provide power, but also help stabilize the spacecraft during its rapid spins. Juno is a spin-stabilized probe, rotating several times per minute to ensure its instruments can sweep across Jupiter's cloud tops and deliver high-resolution data. Equipped with a sophisticated suite of instruments, Juno carries out its mission with a multi-pronged approach. The onboard Juno cam captures breathtaking visible light images, while the microwave radiometer, MWR, peers deep into the planet's atmosphere, revealing layers hidden beneath the churning clouds. Its magnetometer, MAG, maps Jupiter's intense magnetic field in unprecedented detail, exposing subtle variations between the hemispheres. Additional instruments such as JADE and JEDI analyze the charged particles streaming through Jupiter's magnetosphere, and the ultraviolet spectrograph, UVS, captures dazzling auroral displays at the poles. Each instrument is designed to answer specific questions. How much water does Jupiter hold in its deep atmosphere? What is the true nature of its core? Solid, liquid, or something altogether different? And what processes drive the incredible storms and cyclones observed on the planet's surface? Juno's mission aims to answer these questions, providing scientists with data that challenge long-standing theories about giant planet formation. The journey itself was filled with challenges. On its way to Jupiter, Juno performed a critical Earth flyby in October 2013, using our planet's gravity to slingshot it toward its destination, a maneuver that saved both time and fuel. Once at Jupiter, the spacecraft's highly elliptical orbit allows it to approach the planet's cloud tops very closely, sometimes within a few thousand kilometers, before swinging back out to safer distances to avoid the worst of Jupiter's intense radiation belts. NASA's Juno mission is a technical achievement and a story of human curiosity and the relentless pursuit of knowledge. It has already transformed our understanding of Jupiter, revealing details that were once the stuff of theory and speculation. The mission continues to extend its life well beyond its primary objectives, with an extended mission that now includes close flybys of some of Jupiter's largest moons, promising even more surprises in the years to come. As Juno continues its celestial dance around Jupiter, every orbit brings us closer to understanding the dynamic processes that govern not just this giant planet, but also the very origins of our solar system. Its journey is a testament to our desire to explore the unknown, and it is redefining what we know about the cosmos. Diving beneath the clouds, Jupiter's turbulent atmosphere, and surreal storms. Jupiter's atmosphere is a realm of extremes, a dynamic cauldron of swirling winds, deep-seated storms, and atmospheric phenomena that defy simple explanations. At first glance, the planet's vibrant bands of color seem to be nothing more than beautiful, albeit chaotic cloud formations. However, as scientists have discovered through decades of observation, and now with the unparalleled insights provided by Juno, these cloud layers are the surface of a profoundly complex and turbulent system. One of the most striking features of Jupiter is its famous Great Red Spot, a gigantic storm that has been raging for at least 350 years. This colossal vortex, once large enough to swallow several Earths, is not merely a surface phenomenon. Recent data from Juno suggests that the storm's roots extend deep into the atmosphere, potentially hundreds of kilometers down. In addition to the Great Red Spot, Juno's high-resolution imagery has revealed clusters of cyclones near both of Jupiter's poles. At the North Pole, 8 or 9 immense cyclones are arranged in a near-perfect geometric pattern, while the South Pole hosts a slightly different configuration, with 5 or 6 cyclones forming a mesmerizing dance around a central vortex. Imagine a storm so deep that its influence is felt not only on the surface, but far beneath the visible clouds. A hidden world where temperatures, pressures, and chemical compositions shift dramatically with depth. Juno's microwave radiometer has been instrumental in peeling back the layers of this mystery, revealing temperature gradients and chemical distributions that challenge our understanding of how such colossal storms can persist over time. This breakthrough has not only intensified the debate among scientists, but also sparked a renewed sense of wonder about what else might be hidden in Jupiter's depths. Beyond these polar cyclones and the storied Great Red Spot, Jupiter's atmospheric bands, alternating zones of light and dark, extend deep into the planet's interior. While the colorful bands we see from Earth are only the outermost layer, Juno's observations have shown that these jets and currents penetrate far below, revealing complex interactions between deep atmospheric dynamics and the planet's rotation. For example, data indicate that the winds, which can reach speeds of up to 600 kilometers per hour, are not uniform. They vary in both strength and direction as one moves vertically through the atmosphere. Some storms appear to be tall, extending many tens of kilometers below the cloud tops, while others seem more confined to the upper layers. Additionally, the presence of lightning and electrical discharges in Jupiter's atmosphere, detected by Juno's suite of instruments, underscores the planet's dynamic nature. Unlike Earth, where lightning is primarily associated with water-based storms, Jupiter's lightning may be driven by ammonia-water interactions, or even entirely different processes occurring under extreme pressures and temperatures. These revelations have forced scientists to re-examine old models and develop new theories to explain the mechanisms at work in such a massive, energy-driven system. The interplay of heat, pressure, and chemical reactions in Jupiter's atmosphere not only creates a visual spectacle, but also holds clues to the planet's internal structure and evolutionary history by comparing observations from different wavelengths, from visible light to microwaves. Juno is piecing together a three-dimensional picture of this turbulent layer. Every new orbit, every close flyby, brings with it data that make Jupiter's atmosphere appear more as a living, breathing entity than a static, unchanging cloud cover. In short, the turbulent atmosphere of Jupiter is a complex ballet of natural forces, each swirl, each storm, telling a part of the planet's long and dynamic story. As we continue to decode these secrets, one thing is clear: Jupiter's atmosphere is not only a key to understanding this giant planet's current state, but also a window into the processes that shaped our entire solar system. Magnetic wonders and the fuzzy core, revealing Jupiter's inner secrets. If Jupiter's atmosphere is a stage for colossal storms, then its interior is full of mysteries. One of the most startling revelations from the Juno mission is the nature of Jupiter's core. For decades, scientists assumed that Jupiter, like Earth, possessed a well-defined solid core surrounded by a thick envelope of hydrogen and helium. However, Juno's gravity measurements and other observations have upended that conventional wisdom, suggesting instead that Jupiter's core is fuzzy or diffuse, a vast diluted mix of heavy elements and metallic hydrogen, rather than a compact, rocky sphere. This fuzzy core concept implies that Jupiter's formation was far more chaotic than previously thought. In the standard core accretion model, a solid core forms first and then rapidly accrete a massive envelope of gas. But if Jupiter's core is indeed diffuse, it may be the result of a very big collision in the early solar system, an impact that disrupted and mixed the core's material with the surrounding gases. Such a scenario would not only explain the unusual structure of Jupiter's interior, but also provide clues about the violent processes that shape the young solar system. Complementing this mystery is Jupiter's magnetic field, one of the most intense and peculiar in the solar system. Juno's magnetometer, MAG, has revealed that Jupiter's magnetic field is not a simple dipolar structure like Earth's. Instead, it displays complex asymmetries between the northern and southern hemispheres. For example, while the field emerges from the north in a long banded structure, it appears more compact and intense in the south. This dichotomy may be directly linked to the nature of Jupiter's fuzzy core and the dynamics of its deep interior. Researchers now speculate that the complex interaction between metallic hydrogen, turbulent convection, and remnant heavy elements gives rise to the unusual magnetic patterns observed. The interplay between the fuzzy core and the magnetic field is more than just a curiosity, as it has profound implications for our understanding of planetary formation. A diffuse core suggests that the processes leading to the formation of giant planets are not as straightforward as once believed. Instead, they may involve extended periods of gradual accretion, interrupted by cataclysmic events that redistribute material throughout the planet's interior. These findings are prompting scientists to revisit and refine their models of giant planet formation, taking into account the possibility of non-adiabatic interiors and complex mixing processes. Furthermore, the deep internal structure of Jupiter plays a crucial role in driving its atmospheric dynamics. The energy generated by the slow contraction and cooling of the planet, coupled with internal heat from possible radioactive decay and the remnants of formation, is believed to fuel the powerful jet streams and storms that we observe on the surface. In this way, the mysteries of Jupiter's core and magnetic field are inherently linked to its outer appearance, a connection that Juno's varied observations are now beginning to illuminate. Still, the story does not end here. As scientists continue to analyze Juno's data,
actually use the data to understand what's going on in Jupiter.
New questions arise. How exactly do the turbulent motions deep within Jupiter influence the magnetic field observed at the surface? Could the fuzzy core be a remnant of an even earlier stage of planetary formation, one that we have yet to fully understand? And what does this tell us about the formation of giant exoplanets beyond our own solar system? Every new orbit of Juno around Jupiter brings us closer to answering these questions, painting a picture of a planet that is as dynamic and unpredictable as it is massive. Jupiter's inner secrets remind us that even the most familiar celestial bodies can harbor mysteries that challenge our fundamental understanding of physics. The interplay of a diffuse core, dynamic convection, and an extraordinary magnetic field paints a picture of Jupiter as a living, evolving entity, one that continues to surprise and inspire scientists and space lovers alike. But what about the moons that orbit this giant? Could they hold the key to unraveling even more of Jupiter's mysteries? The celestial dance, Jupiter's moons, and their mysteries. No exploration of Jupiter would be complete without turning our gaze to its retinue of moons, the Galilean satellites that have captivated observers since Galileo first noted them in 1610. Io, Europa, Ganymede, and Callisto each present a unique puzzle carefully linked to Jupiter's own evolution and magnetic environment. Together, these moons perform a cosmic dance that not only enriches our understanding of Jupiter, but also offers tantalizing clues about the potential for life beyond Earth. Io, the innermost and most volcanically active of Jupiter's moons, is a world of fire and fury. Its surface is scarred by hundreds of active volcanoes that spew sulfur and other materials, creating vivid, ever-changing landscapes. Juno's close flybys have provided unprecedented images of Io's volcanic plumes and lava fields, revealing details that were once beyond our grasp. The energy driving Io's constant volcanic activity is a product of the tidal forces exerted by Jupiter's massive gravity, a force that stretches and compresses the moon, generating heat deep within its interior. In stark contrast stands Europa, an icy world whose smooth, fractured surface hints at an ocean hidden beneath. While the surface appears to be a frozen shell, numerous observations suggest that a vast ocean of salty water lurks below, making Europa one of the prime targets in the search for extraterrestrial life. NASA's upcoming Europa Clipper mission, along with data from Juno's extended flybys, aims to scrutinize this moon further, probing its surface composition and the possible exchange of material between the ocean and the icy exterior. Ganymede, the largest moon in the solar system, is a world unto itself. With a diameter larger than that of Mercury, Ganymede boasts its magnetic field, a rare trait among moons. Juno's encounter with Ganymede has offered glimpses of its complex geology and magnetic interactions, contributing to our broader understanding of how such satellites evolve. Callisto, the outermost of Jupiter's Galilean moons, boasts one of the oldest surfaces in the solar system. Its heavily cratered terrain is remarkably unchanged, preserving an untouched record of impacts from billions of years ago. Unlike its more geologically active siblings, Callisto shows little evidence of tectonic or volcanic activity, offering scientists a unique window into the early conditions of the Jovian system. This time-worn world provides extremely valuable and unique clues about the formation and evolution of our planetary neighborhood. The relationship between Jupiter and its moons goes far deeper than mere gravitational attraction. These satellites are intimately connected to Jupiter's magnetosphere, with processes such as the Io flux tube, demonstrating how material from a moon's atmosphere can interact with the planet's magnetic field to create spectacular auroral displays. For example, charged particles stripped from Io's volcanic emissions are funneled along magnetic field lines toward Jupiter's poles, generating localized auroras known as the Io footprint, a phenomenon observed both in ultraviolet images and in radio emissions. The celestial dance of these moons is not static. Their orbits, resonances, and interactions evolve, influencing not only their geology, but also the dynamics of Jupiter's extensive system. The gravitational tug-of-war among these bodies can lead to orbital eccentricities that, in turn, drive further internal heating and activity. This complex interplay has major implications for our understanding of not only Jupiter's history, but also the processes that govern satellite systems around giant planets throughout the galaxy. In many ways, Jupiter's moons serve as windows into different aspects of planetary science, from the violent volcanism of Io and the hidden ocean of Europa to the magnetic mysteries of Ganymede and the primordial surface of Callisto. As we continue to gather and analyze data from Juno and future missions, each moon adds a new layer to the rich tapestry of the Jovian system. Their individual stories are woven together by the immense gravity and magnetic forces of Jupiter, forming a celestial symphony that challenges and expands our view of what is possible in a planetary system. Echoes from the past, revisiting Jupiter's formation and evolution. Jupiter's current state, its swirling storms, diffuse core, and complex moon system are a direct consequence of its chaotic birth and evolution. For decades, astronomers have debated how this giant planet formed. Traditional models based on core accretion posited that a solid core, roughly 10 to 15 Earth masses in size, first coalesced from the primordial solar nebula and then rapidly accreted a massive envelope of hydrogen and helium. However, the startling discovery of a fuzzy core by the Juno mission suggests that Jupiter's formation was more complex than previously imagined. One possibility is that Jupiter's core was subjected to a giant impact in the early days of the solar system, a collision that mixed heavy elements into the surrounding envelope, creating a diffuse, extended core. Alternatively, the formation process itself might have been prolonged, with a slow accretion phase that allowed heavy elements to gradually blend with the lighter gases. These new insights have forced scientists to rethink standard formation models and consider hybrid scenarios that could account for the observed distribution of mass within the planet. The story of Jupiter's evolution is also intertwined with the broader narrative of the solar system's development. Jupiter's enormous gravity not only helped shape its structure, but also influenced the orbits of the other planets, the distribution of asteroids, and even the eventual emergence of Earth as a life-bearing world. Its migration through the early solar nebula may have cleared vast regions of gas and dust, while its gravitational interactions with nearby bodies could have triggered events like the Late Heavy Bombardment, a period marked by intense asteroid and comet impacts throughout the inner solar system. Juno's measurements of Jupiter's gravitational field have provided new constraints on these formation models. By mapping subtle variations in gravity, scientists can infer how mass is distributed deep within the planet, and, in turn, piece together a more detailed history of its growth. These data suggest that Jupiter may have accumulated heavy elements at a rate and in a manner that defies the simple picture of rapid core accretion. Instead, the evidence points toward a more subtle and perhaps chaotic process, one that involves multiple phases, collisions, and episodes of mixing. Furthermore, the ongoing study of Jupiter's formation has broader implications for our understanding of giant exoplanets. Many of the gas giants discovered orbiting distant stars exhibit properties that challenge our conventional theories. By studying Jupiter up close, we gain a valuable benchmark, a natural laboratory in which the fundamental processes of planetary formation can be observed and tested. As new telescopes and missions begin to study exoplanetary systems, the lessons learned from Jupiter's evolution will serve as a critical guidepost. In essence, the echoes of Jupiter's formation are felt throughout the solar system. They remind us that the birth of a planet is not a simple, linear process, but a dynamic interplay of forces that can result in surprising outcomes. Juno's revelations about the planet's internal structure and composition are not just snapshots in time, as they are keys that unlock the long-hidden history of a giant that has shaped the destiny of countless worlds. But what happens next? With Juno's extended mission, the next chapter of Jupiter's exploration promises to be even more groundbreaking. Extended missions and future horizons. What's next in Jovian exploration? The Juno mission has already transformed our understanding of Jupiter, but its journey is far from over. Initially set for a relatively short primary mission, Juno's robust performance has paved the way for an extended mission that promises even more major discoveries. With plans now extending until September 2025, Juno will continue to orbit Jupiter, making closer and more frequent passes over the planet and its intriguing moons. This extended mission is particularly exciting because it opens up new avenues of research. For the first time, Juno will conduct dedicated flybys of some of Jupiter's largest moons, Ganymede, Europa, and Io. These encounters will allow scientists to gather high-resolution data on their surfaces, gravitational fields, and magnetic environments. Each flyby offers the potential to uncover new details about these satellites, from the volcanic landscapes of Io to the icy, potentially life-sustaining oceans of Europa and the complex geology of Ganymede. Looking ahead, several future missions are set to build upon Juno's legacy. NASA's Europa Clipper, for example, is scheduled to launch in the coming years and will focus on probing Europa's ice shell and subsurface ocean in even greater detail. At the same time, the European Space Agency's JUICE, Jupiter Icy Moons Explorer mission, is on track to explore the Jovian system with an emphasis on Ganymede, Europa, and Callisto. Together, these missions promise to create a comprehensive picture of Jupiter's environment, from its deep interior to the dynamic interplay with its moons. The prospect of continuous exploration is thrilling because every new dataset has the potential to rewrite textbooks. With each orbit, Juno is testing our theories about Jupiter's magnetic field and core, and also setting the stage for the next generation of explorers. The extended mission will help answer lingering questions about the planet's formation and evolution, while simultaneously uncovering new mysteries that will drive future research. In this sense, the exploration of Jupiter is a never-ending journey. As we gather more data and refine our models, we begin to appreciate the true complexity of this enormous planet and its far-reaching influence on the solar system. The extended Juno mission, along with upcoming spacecraft like Europa Clipper and JUICE, ensures that our quest for knowledge continues, with each mission building on the successes of its predecessors and opening up new frontiers in planetary science. As we press forward, Jupiter's secrets seem endless, each discovery sparking more questions than answers. What will future missions uncover about this enigmatic giant and its moons? Questions, speculations, and the future direction. Even after years of intense observation and analysis, Jupiter still holds many secrets that provoke more questions than answers. What exactly causes the extraordinary stability of the polar cyclones? How does the mysterious fuzzy core affect not only the planet's magnetic field, but also its overall evolution? And what role do Jupiter's moons play in influencing its atmospheric and magnetic dynamics? These questions are not simply academic. They are the driving force behind every new mission and every fresh dataset. Scientists are now engaging in lively debates, speculating about scenarios that might explain these phenomena. Some researchers suggest that early collisions during Jupiter's formation left behind a diffuse mixture of heavy elements, while others propose that ongoing dynamic processes continue to reshape the planet's interior. Likewise, the unusual structure of Jupiter's magnetic field, with its pronounced differences between the hemispheres, hints at complex interactions deep within the planet that we are only beginning to understand. Speculation also extends to the broader implications of these findings. If Jupiter's core is indeed spread out, what does that mean for our models of giant planet formation in other solar systems? And if the processes observed on Jupiter are common, Could they be responsible for the wide variety of magnetic and atmospheric phenomena seen on exoplanets? These are the kinds of questions that keep scientists awake at night, and they are the very questions that make space exploration so compelling. Beyond the scientific community, Jupiter's mysteries have a way of capturing the public's imagination. The idea that a planet so massive can harbor secrets that challenge our understanding of physics, chemistry, and even the origins of life is nothing short of mesmerizing. As we continue to watch Juno's data stream, and as future missions launch, we can expect more surprises, more debates, and more thrilling revelations that push the boundaries of what we know about our solar system. In many ways, our journey with Jupiter is a metaphor for scientific inquiry itself. Each answer leads to new questions, and every discovery opens up a new realm of possibility. As we stand on the brink of even more daring missions, each one promising to shed light on the darkest corners of this magnificent planet, we are reminded that the quest for knowledge is never truly complete. The road ahead is long and filled with mystery, but it is also incredibly exciting. So, as we look to the future of Jovian exploration, one thing is certain: the legacy of missions like Juno will continue to inspire and inform for generations to come. With every orbit, every flyby, we take one more step on a journey that may one day reveal all of Jupiter's secrets. Until then, we remain curious, ever questioning, and always eager to explore the unknown. And that wraps up our in-depth look into Jupiter's biggest secrets, exposed by NASA's Juno mission images. We have traveled from the bright, stormy skies of this huge planet to the mysteries hidden deep within its spread-out core, and even explored the captivating dance of its moons. Yet, as always in science, every answer brings new questions, leaving us with more to ponder and explore. If you enjoyed this voyage through Jupiter's secrets, please hit that like button, share your thoughts in the comments below, and subscribe for more explorations of our amazing universe. Do not forget to check out our next video, where we continue to unravel the mysteries of space. Thanks for watching.